Hello, everyone. Welcome to today's webinar. It's titled Concrete Moisture and How It Impacts Floor Covering Installation. I'm Jim Olson with the National Tile Contractors Association, and I want to welcome you and thank you for taking the time out of your busy schedule to attend today's webinar sponsored by Custom Building Products. Before I introduce today's speaker and our program, I want to remind you that during the webinar, you will be muted. Please use the questions area on your computer to type in your questions, and we'll answer those at the end of this presentation. If the audio on your computer is poor, call the number on the invite to this webinar and listen on your phone. All NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after the webinars are presented, giving you easy access to watch and or share all current and past programs at your convenience. All right, I'm proud to introduce today's presenter, Howard Jancy. He's the Commercial Architectural Service Representative for Custom Building Products and has over 30 years experience with tile, stone, and concrete flooring design, installation, and remediation. His responsibilities include specification writing and review, technical services, and continuing education. Howard has had articles published in Landscape Contractor National Magazine and the Journal of Architectural Coatings. He works with the contractor, distributor, designer, specifier, and owner through all project phases. He understands the complexities and capabilities of a building product's attributes to meet the architect's requirements and the owner's vision. Welcome, Howard. Looking forward to your presentation.
Thank you, Jim. Thank you, NTCA, for the opportunity. And I'd like to thank my audience for giving me an approximate hour today to talk to you about concrete moisture in concrete. The program is compliant for AIA continuing education credit. So at the end of the program, we'll be registering your attendance. If you want a certificate of completion or attendance, I can also send those out. Custom Building Products, if you're not familiar with us, we're a tile setting manufacturer or a tile setting material manufacturer. We also make a variety of products, adhesives for soft or other flooring in addition to tile. And obviously with today's program, concrete moisture, it impacts or can cause problems with all types of flooring systems. Measuring it, the mitigation is quite simple, but oftentimes becoming aware of it, being proactive, that's where the tricky part lies. So we're going to look at concrete from mixed design through installation and maybe all the potential pain points or problems that can show up. And again, how do we resolve those issues? Take a look at the left there. We see a variety of flooring types, floor coverings that can have problems if there's excess moisture leaving the concrete slab. The flooring product itself can deteriorate, or often too, the adhesive, the setting material underneath that flooring product can also suffer. Now, if we take a look at porcelain tile, it's not as sensitive to moisture vapor. We install tile in showers, in steam rooms, wet areas outside exposed to the elements. It performs quite well. However, the typical setting materials that you'd use for tiles, those can have problems with moisture vapor leaving the slab. So it pays to talk to or read the tech data sheets for all the products you intend to use on your project to see what limits and suggestions the manufacturer provides for correctly installing their product in a damp type environment. And I mentioned a porcelain tile, it can hold up or work in a wet environment. All flooring that's shown on here can have problems with expansive alkaline deposits, causing disbonding of the flooring product, as well as issues with moisture vapor pressure. So realistically, moisture is going to affect everything you're going to cover the floor with, one way or the other. Expansive salts, again, can disbond and cause deterioration of the flooring, as we see here. As I mentioned already, you need to take a look at your at the flooring manufacturers, adhesive manufacturers, setting material manufacturers, tech data sheets, and see what their recommendations are or where red flags may exist. But bottom line, the alkaline deposits do not happen, will not happen, unless there's moisture leaving or present in the slab. Today's presentation will do nothing for this particular issue here. If you have the fountain in the center of your floor, this is hydrostatic pressure and maybe some other issues, but nothing we're going to talk about today really address what we see here. We're more concerned with moisture that you can't see, you can't feel, that you really don't know is there until there's problems with the floor covering. We could have re-emulsification of the adhesive. You're going to lose the tile bond to the substrate. You could see bubbling, as we see here, or blistering. This can be a product of moisture vapor pressure pushing up and forcing or creating those blisters underneath the vinyl product. Here we're looking at an epoxy coating that has I'll call it a decorative flake embedded into the surface. Most people think that epoxies have a very tenacious bond, and indeed they do. But some epoxies, if they're not formulated for exposure to moisture, excessive moisture, if they're not formulated for exposure to alkaline salts, can fail. So as I already mentioned, any and all floor coverings will suffer from excess moisture vapor in the concrete. And something as simple as carpet, you have staining on the surface and the potential for mold growth. So again, moisture mitigation is even important under this type of installation. If we take a look at the wood floor, the lower right, we see cupping or upward curl of the wood components. This is a permanent problem. Once the floor dries out, that curl can be permanent. On the upper left, we see a tenting of the tile, a product of the wood swelling because of moisture and likely the lack of expansion joints between the wood pieces. So again, both these problems are sort of permanent issues even when the moisture dissipates or is not present any longer. Here we see some severe tenting of a wood floor. There's different reasons or causes to get here, whether when it's over new concrete, there's moisture in the concrete. But I think the most important takeaway from these three pictures is the third one here, that moisture testing, moisture evaluation of problems should be done before you have a problem, before the floor is installed. So being proactive as opposed to reactive is the best medicine to avoid some of the issues we're looking at or just saw through some of those slides just shown. This is a moisture problem. A lot of people may attribute it to damp or wet wood from the moisture, and it'll disappear once that moisture disappears, and that's not really the case. Many species, woody species, have tannins or tannic acid, oak being one of those species with a high concentration of tannic acid. These tannins are water soluble, so moisture from underneath the slab will push them or push them into the surface, as we see here. And it's the alkalinity of the moisture that increases the darkening effect. This will dissipate once the moisture source disappears or the tannin concentration in the wood dissipates. But it's a tough problem to remedy, and I'm not sure if sanding is a remedy or how you would approach it. But again, a problem with wood flooring with excess moisture. And here we see that again, tannins staining the wood floor. But why is it in such a perfect line, a perfectly rectangular shape, and just in the center of the floor? And the answer we show or see in the next slide. They installed a electrical receptacle in the floor, and they had to trench the concrete. When they trenched the concrete, they removed the vapor barrier underneath it. When the concrete was replaced, they did nothing to do to make that slab or trench water or vapor tight. So moisture came up, stained the concrete with tannic acid. So the floor, prior to the wood being installed, was perfectly dry. Once they had trenching done and compromised the vapor barrier underneath, they had a problem for the life of that floor potentially. So if you're ever working over floor that has extensive trenching or full depth patching, you may want to make the assumption that that floor will no longer be dry. And in this condition here, or with the previous floor, you can selectively apply a moisture mitigation membrane just over the trench, a few inches to either side of the trench, and you probably have your problem solved. There's really no reason to mitigate or apply moisture mitigation membranes over that whole floor, whole slab. Save some time and money in the process by being selective where it needs to be applied. Here we're looking at the bottom slides. That could be representative of stone or any type of porous tile where you have moisture coming up, where you have moisture staining. Or if we take a look at the upper slide, we have a substrate or a tile, probably a stone, that is not as resistant to moisture. It's not as porous, but the grout joints, which are typically cementitious, you could have moisture driven through those grout joints, creating mineral salt deposits or efflorescence on the surface. So in many instances, the floor coverings, such as in these slides, are not physically damaged, but you have aesthetic issues with the moisture coming to the surface over time. On the left, we see a concrete block out around the column, isolating the column from the floor that was poured. Reason being, if you pour the floor up against the column, you will have cracks radiating into the floor starting at that column. Now take a look at the right photo. You could see exactly where that concrete blockout exists because you had moisture come up through the blockout. And the reason that happened, we have the footing that the blockout or the column is sitting on. That's sitting on soil. You're drawing moisture up through the footing into the blockout, causing the moisture problem or moisture staining. And what should have been done prior to the flooring installation was possibly or probably selectively applying moisture mitigation around that column, covering the blockout and a few inches beyond. And if you take a look at the picture on the right, you can notice coming in the doorway and next to the locker, there seems to be darkening. So it looks like they've got moisture issues throughout this slab. So typically when you're installing a concrete floor like this, you've got possibly a moisture vapor barrier under the concrete, but no one thinks about that concrete blockout being a moisture source damaging the floor covering. Many years ago, we moved from solvent-based materials to water-based, and with the adhesive that were available, water-based products are more sensitive to moisture. They can re-emulsify, or high alkalinity, high alkaline environment can also defeat or cause damage to adhesive. Nowadays, many of the adhesive manufacturers have made great strides, if you will, in reformulations where their water-based products can hold up to moisture vapor. But this was the start of a problem many years ago, that water-based were just not as good as solvent-based, petroleum-based materials. Another issue is mix design. We see SCM, supplementary cementing materials. Those materials, a typical one is called fly ash, is used to reduce some of the Portland cement in a cubic yard of concrete. And fly ash is a product of coal burning power plants. The particulates, rather than being emitted, are captured. And this fly ash is a very fine powder. It's 1/10 the size or diameter, if you will, of Portland cement. And when this product is added to Portland concrete cement, Portland concrete, in addition, it gives you a less expensive cubic yard of concrete potentially, but it also provides or produces a denser, stronger, more impermeable concrete. So a lot of good things are done or happen because of fly ash added to Portland cement. However, the big however, it requires more drying time. That fly ash is a very small particle, 1/10 the size of cement, so it's distributed throughout that concrete binder, cement binder we see on the left. And those dark spots shown by the arrow, those are pores. So again, that very fine material makes it difficult for water to leave or bleed from the concrete. So again, you have more drying time compared to a cubic yard of concrete with straight Portland cement in its mix design. Lightweight concrete, often used on elevated slabs. The lightweight concrete reduces the structural load on the steel. And lightweight concrete is done or manufactured using lightweight aggregates. And you could see the difference in weight from a typical concrete to lightweight concrete, reducing, again, the load on structural steel. And the quality of these lightweight aggregates is they tend to be porous. And it's that porosity, or they're not as dense as your standard aggregate that we see here. So the downside of lightweight aggregate or porous aggregate, it retains moisture. So you're going to have a longer drying time compared to a standard aggregate, if you will. And what is the drying time? Approximately about 160 to reach 3 pounds of moisture, or 180 to reach 75% RH. And compare that to a standard weight or typical weight concrete, a fraction of the time. And what's the significance of the 3 pounds and the 75%? Well, that comes from an ASTM standard. You could read the title there, Resilient Flooring. And this standard, if you read through it, is applicable to other types of flooring. And most manufacturers, unless manufacturers have state different values, this is the maximum amount of moisture you want emitting from a concrete slab, 3 pounds and 75%. So it's very important to read the tech data sheet from your various flooring manufacturers' products, as well as their setting materials. What is their limitations? Because they may have different numbers than what's stated here. But for the most part, you'll see limits 3 to 5 pounds and 75% are pretty consistent throughout the industry, flooring industry, if you will. And one that probably we face on every job is to hurry up and get done. Flooring products are one of the last things or materials to be installed. Budget is out of whack. Scheduling is out of whack. And you're told as a flooring contractor, hurry up and get it done. And that in itself can create problems, because we know, or it's very likely, the slab isn't sufficiently dry for your flooring product to be installed. And sufficiently dry means 3 pounds of moisture or 75% RH. So for the next few slides, we'll look at some of the things we need to be concerned with as far as moisture in concrete and how quickly it dries, mix design, how it's handled by the contractor in the field, humidity and temperature conditions during and soon after installation, as well as some other job site conditions. Now, I think it's important to establish the difference between curing and drying. Curing requires moisture. Curing is really, in a sense, is a chemical reaction. When you add water to cement, there's a bunch of chemical reactions that happen. Again, it's catalyzed or starts with moisture. You need an ideal temperature for that chemistry to happen, and it has to be over a period of time. But generally speaking, concrete is considered fully cured at about 28 days. Now, drying is almost polar opposite. Drying means you've got to get moisture out of that slab. And the way it typically leaves the slab is through evaporation. The water bleeds to the surface and evaporates to the air. Settlement or gravity taking out of the bottom. And again, there's numerous chemical reactions as that concrete is curing, so water is consumed during those reactions. And the unwritten rule of thumb for concrete drying is about 30 days per inch of concrete. So if you have a 5-inch slab of concrete, you've got approximately 5 months of drying time ahead of you. And that drying time can vary because of temperature and humidity. Cool temperature, high humidity, longer drying times. So curing is very important to give the concrete strength. Drying is very important to give you a sound substrate, a correct substrate for installing impermeable floor covering and setting materials. And very important to minimize moisture in concrete. Design concrete, the mix design is very important. What is the recipe for the concrete? Low water to cement ratio, we'll talk more about that. You don't want to add water during the installation, but that often happens, unfortunately. You can get water from the subsoil, the subgrade underneath the concrete. So we have to be proactive and take care of that even before we start the installation of the concrete. And again, once the concrete is installed, can you promote drying? Can you promote curing so that when flooring is installed, you've got the best conditions available? Water cement ratio, keeping it simple, is the amount of water in pounds to the amount of cement in pounds. And the typical water cement ratio is about 0.45. You can go lower, but generally you're not going higher because too much water, strength, and you may lose durability at the surface. In a 0.45 water cement ratio, again, means about 30 gallons of water per cubic yard of concrete. So all or most of that moisture has to dissipate or disappear before we start installation. And too much water, again, might seem like a benefit. It makes the concrete easier to install because it's much more fluid or flowable, but you lose strength and you lose durability at the surface if that water cement ratio is not followed or ignored in the field by adding water to the concrete. So water cement ratio is taken care of by the specifier, and it's generally in this range. Where the problem starts, even with a perfectly designed concrete, is once the concrete moves to the job site, you have a concrete contractor installing the product, and what that contractor should not do is randomly add water. Here we have, it looks like a slab being placed on a vapor barrier. You've got lots of steel there, and the contractor is applying water to probably help that concrete move under, around, and through that rebar. Now, this water may not affect the strength of the concrete since it's not being mixed in, but that's excess water now that has to evaporate or dissipate before we can install tile. And we don't know when we get on a concrete slab if this occurrence, if this water added happened or not. But again, it's a potential source for moisture, that extra moisture that we have to worry about. Vapor barrier underneath the concrete. Moisture found in the subgrade, in the soil, can extend the drying time in the concrete, and it could be possibly pumping moisture into the concrete for the life of that slab. So this problem or issue or concern is pretty easily resolved by installing the concrete over a moisture vapor barrier. A plastic sheeting that could be manufactured specifically for this purpose. It's important when using a moisture vapor barrier that the seams are taped, penetrations are taped, to make those seams and penetrations vapor tight so you don't have moisture coming up at these breaks in the membrane. Oftentimes these sheets are manufactured specifically for that purpose, or generic polyethylene plastic sheeting can also be used for a moisture vapor barrier. But an issue here. You've got a several ton ready-mix truck driving over this plastic, and as those pneumatic tires roll over the plastic, possibly shearing along as they roll across the surface, you're introducing pinholes. So you've just defeated the benefit of that moisture barrier by driving a ready-mix truck over it. And sort of the same issue here. We've got a laser-mounted screed, pneumatic tires driving over that moisture membrane. Are you popping holes in it? And this is something we don't know once we start our flooring installation. Has this situation occurred? Has this problem occurred? Something that we need to have to think about, or assume that the problem occurred and be proactive with moisture mitigation. Once the concrete is placed, we want to retain moisture in the slab for at least 28 days. We need moisture to promote concrete curing, cement hydration, strength gain, etc. This is a very effective means, putting down a sheet, pervious paper or plastic. The challenge here, especially with this very large insulation, is keeping that sheet down where the wind doesn't blow it off, etc. But once that concrete is cured at 28 days, you need to remove it to allow drying to start. As long as that sheet sits on the surface, drying is inhibited or greatly delayed. More popular or common is the use of a spray applied curing compound. This forms a mostly impermeable film that holds moisture in the slab, and this needs to be removed after 28 days because potentially it will be a bond breaker to flooring setting materials, adhesives, mortars, membranes, etc. can debond or disbond because of its presence on the surface. There's different types of curing compounds. There's dissipating that require exposure to sunlight over a period of time. If this is being used, one needs to verify that the curing compound has indeed dissipated. Any remnants of the film on the surface can be a bond breaker. There are non-dissipating curing compounds. These definitely have to be removed, and you're talking mechanical abrasion, mechanical means to remove it. And there may also be some compatible curing compounds depending on their chemistry. And compatibility is often determined by the manufacturer of the setting materials or adhesives. They'll take their product, apply it over these select curing compounds, meaning silicate or acrylic resin based, and see how well they get bond. But bottom line, curing compounds, if they're not dissipating or compatible, definitely think about removing them from the slab prior to the flooring installation. So at this point, we've done everything correct. We've got a great mix design. We didn't add water to the concrete. We've got a vapor barrier underneath the concrete. Now we're gonna let that concrete dry. What can go wrong? Well, we see it here. If it rains, if a plumbing pipe bursts or leaks, if they wash the floor or flush it with water, if the fire sprinkler system burst or leak, we've got water added to that slab. And remember when I said it takes 30 days for every inch of concrete to dry? Well, the minute you introduce water again to that slab, a rainstorm, that clock starts ticking again. And as a contractor, you're walking on a job, you don't know what's been done to this concrete slab. The mix design, vapor barrier underneath it, what was it exposed to other water? So again, you have to worry about possibly being proactive with moisture mitigation. In this particular situation, you could possibly wait longer for drying, but that's money. And even when you're giving it time to dry, do you know if you've hit 3 pounds and 75% moisture? Probably not. You can enclose the area, run various fans and dehumidifiers, etc. It's not a quick process, but again, you don't know if the slab is dry enough for floor covering, 3 pounds and 75. So what's left? Moisture testing and moisture mitigation. As far as relevant standards, there's a standard for the 2 common tests, calcium chloride test and relative humidity test. It's important to note that these measure moisture in different ways and at different times, and you can't correlate one versus the other, meaning if you know the MVER, moisture vapor emission rate, you can't extrapolate that to a percent RH, or if you know the RH, you can't extrapolate that out to the pounds of moisture. And whereas this is important is depending on the flooring manufacturer, the setting material manufacturer, they may prescribe a specific test, either calcium chloride or relative humidity, to be used with their product or prior to using the product, or even both. So it's important to note what your flooring suppliers or manufacturers are requiring, what type of test and what those limits are, 3 pounds or 75% moisture. Also, ASTM 710, we saw that earlier. That's where we got the values of 3 pounds and 75%. But there's other prescriptions in this standard as far as dry time, which can be affected by ambient temperature and humidity. Also, pH testing is required as part of this standard. Some flooring materials, as well as their adhesives, require a lower pH than what you get with new concrete or concrete that has moisture being drive through the slab. And if you don't have a high pH, a high pH is not possible unless you have moisture present. And as I mentioned earlier, ASTM F710 says it's for resilient flooring, but other flooring manufacturers will conform to the requirements in this standard. As far as the moisture testing, the two popular methods are calcium chloride on the left, where they have a dry material, calcium chloride. They weigh it prior to installation, place it on the concrete, covered with a hood for a prescribed amount of time, weigh it afterwards, and from the difference in weight, it's pounds of moisture. The RH test or method is they're inserting a probe into a preformed or a drilled hole. And again, they measure from that, they can extrapolate or measure percent moisture. So these are the two popular tests, and I would suggest reading those ASTM standards for the specific requirements or instructions on how to do these tests correctly. In the case of the RH test, the probe depth is specified as we see here. If the slab is drying from the top, they want the probe to be placed deeper than when the slab is drying from both top and bottom, so that the depth of the probe as well as distribution, the number of probes, is very important, and that's clearly stated or described in the ASTM standard. Now let's compare the two and see where the pros and cons lie between these two tests. These are identical slabs, the same slab where the testing is, let's say, several feet apart. So we've got similar or exactly the same moisture conditions both left and right. But let's take a look at the left. We're doing a calcium chloride test. We see the hood over the calcium chloride. And this test typically only measures water or finds water within the top 1/2 to 1 inch of the slab. And at this moment in time, looking at the left, the moisture in the slab is in equilibrium with the moisture vapor in the air. There's nothing really pushing it or pulling it aggressively. So we see on the left there that it says it's at 74% RH. So we need to be under 75. We're good to go. We're going to install some flooring there. But what happens when we install flooring, when it's impervious, impenetrable, impermeable? Now the moisture in the air is irrelevant. Now that moisture that's sitting in the concrete at the bottom wants to equilibrate with the moisture at the top. So all that moisture in the bottom that we didn't know about, because calcium chloride only measures near the surface, is going to want to move to the top, distribute evenly, and all that moisture at the surface is going to push off your flooring, create alkaline deposits, etc., etc. Now, wouldn't it be great if we had a test or means of finding out how much moisture is sitting in the bottom of the slab, sort of a reservoir waiting to come out? And that's what RH testing does for us. You notice the probe, 40% depth, it dips into that other moisture that's sitting at the bottom that we don't even know about with just calcium chloride testing. So we see here on the right, yeah, it's good to go at the surface, but at some point in time, that moisture, 85% plus, is going to rise to the surface. And when is that point in time? When the flooring product is installed. So the more accurate results, if you will, are attained with RH testing, more meaningful results. But again, look at the tech data sheets for your flooring products, for your adhesive. The manufacturer may prescribe one or the other or both to be done. But realize RH testing gives you an idea of what's going to happen down the road, whereas calcium chloride testing on the left tells you what's happening at this moment in time, not weeks or months, weeks later when the installation is scheduled to start. So talk to if you're doing moisture testing, talk to the contractor. He's able to give you some guidance here, but it's the manufacturer of the flooring system and adhesives that is the starting point for your discussions with moisture mitigation contractors. There's different ways to mitigate moisture. I'm not really going to go pro and con with any of these methods here, but most popular, if you will, is the 100% solids epoxy coating. And I say popular just because it has a good track record. But also important, its formulation and performance are governed by ASTM standards. So again, you know what you're getting and its effectiveness. Whereas these other methods, again, not debating, and I'm not an expert in all these other types of products, they may not be governed by standards, so you're not sure what you get performance-wise once it's installed. As far as moisture mitigation, 100% solids epoxy, you could see 1, 2, 3, 4 ASTM standards that you will find in the manufacturer's tech data sheet. Their products conform to these standards. The maximum amount of moisture leaving the surface in perms, 0.085, is what you typically find with moisture vapor control systems. Generally, these products can handle 100+% moisture and 25 pounds plus of moisture vapor emission rate based on the calcium chloride. So these are very important ASTMs to be finding in your supplier's tech data sheet. Also important, 100% solids, alkali resistant, and their penetrance. And when I say penetrance, they're able by formulation to wet or wick into the concrete. If you recall earlier in the beginning of the slide presentation, I showed you an epoxy that was blistering up. Oftentimes, an epoxy will just sit on the surface. It does not penetrate well for a greater or better mechanical lock. So again, these epoxy moisture mitigation systems don't just sit on the surface, they wet in, becoming much more effective for the process or reasons of moisture mitigation. Also, two important qualities of moisture mitigation products, the epoxy moisture mitigation products. They're compatible with all floor coverings and adhesives. If you have multiple floor types being installed, you don't want to have a moisture mitigation system different for each of those. Also very important, warranty, that the supplier of the mitigation membrane not only warrants their product for mitigation, but also the flooring system installed above it. Now, with moisture mitigation membranes, specifically epoxy surface prep is required, and it needs to be aggressive. Here we're looking at a blast track machine that shoots out a small BB that removes weakened concrete contamination, creates a profile, creates porosity. So you need to be aggressive. None of these methods on the right are good prep methods. Chemical and detergent cleaners, if not sufficiently rinsed, can become bond breakers. Acid etching can be very effective for prepping, but if you don't thoroughly neutralize and remove the acid residues, those can become bond breakers at a later point. So mechanical prep is highly advised prior to the installation of a moisture mitigation membrane. There's an organization called ITRI. It has established some prep standards, concrete surface prep standards, 1 through 10, 10 being the most aggressive. And typically for moisture mitigation products, they require a CSP3. And it's aggressive, meaning that to achieve a CSP3, it's an aggressive process, meaning mechanical prepping. Scabling and scarifying are probably much too aggressive for our purposes today. Grinding and shot blasting is what's typically done. And shot blasting may be most effective because grinding, if it's not done correctly or it's not very thorough, you're just removing high points. You may not be removing contamination within the pores of the concrete. But bottom line, any product you're trying to adhere to concrete, just not moisture vapor products, generally ask for or suggest a CSP3 prep for the product. But as I've been preaching all along, read the flooring manufacturer's recommendations, read the setting material manufacturer's recommendations for prep of concrete surfaces. Moisture mitigation, again, takes care of the majority of the concrete surface, but where you have breaks, or in this case, joints in the concrete, those have to be addressed. Joints that are designed to move, open and close with temperature changes or thermal conditions, those need to be filled with a flexible material, a silicone sealant, for example, to maintain or allow that joint to move or function correctly. If you install a moisture mitigation directly over that joint, it's not going to be effective. You'll have a seam where moisture is going to come up. If you have a random crack, it's deemed or considered not to be moving. That can be routed out and filled with a patch created by the moisture mitigation epoxy plus sand and filled in. So cracks and joints need to be properly addressed before you install the mitigation membrane. Also, a problem with ignoring cracks and joints, you're applying that membrane, and that membrane is going to seep into the joint or crack where you're not going to have the required mill thickness or film thickness to do the job. So again, cracks and joints, some prep work is required before installation. Now, the mitigation membrane we see on the left being distributed with a V-notch squeegee, and generally these products are colored or pigmented, so you can have a visual indicator that you're getting overlap between each section or application. Once the film is applied, it's important, the epoxy film is applied, it's important to back roll it. Back roll helps distribute the film. Back rolling also eliminates air or pinholes from forming in the concrete or in the coating. When the epoxy is mixed, you could introduce air into that system that wants to escape once it's placed, or often, or typical, that epoxy membrane, as it's flowing across the surface, penetrates into the pores. As it penetrates into the pores, it pushes out air and these bubbles can form. So back rolling will close these bubbles, will remove these pinholes. If ignored, they're going to be a place for moisture to come up once you install the flooring. So it's very important to make sure that there are no voids, no holidays, no pinholes prior to installing whatever floor covering you choose or specify. And once the membrane is cured, fully cured, depending on whether you're doing soft flooring, meaning something other than porcelain tile, there's various products that need or should be used. Potentially a primer on the left there for soft flooring, skim coat of something, a cementitious skim coat or a leveler that protects the moisture mitigation membrane, your adhesive for the flooring system, the floors covering, and then finally your floor covering. In the case of tile, you may have the need of a leveler plus a primer, may have the need, if required, a specified crack, ISO, or waterproofing mortar, tile, and a flexible sealant for the joints here. So again, left and right there, what I'm showing are just a quick thumbnail or synopsis of what's going to go on or what's going to be installed after the mitigation membrane. But again, for the umpteenth time, talk to your manufacturers of all the materials that are being supplied. What do they recommend for a high RH or a high MVER substrate? Warranty, as I mentioned before, you want a warranty from a membrane manufacturer that's going to cover everything from soup to nuts in the installation, not just the membrane, but also flooring products. There are various manufacturers that do just that. You don't want to have a moisture issue and then have finger pointing on who is responsible for that remediation or corrective action. Now, one thing I found out with some early discussions with some specifiers is the head scratching that goes on. When do I start moisture mitigation? Because there's various concerns with timing and who's going to do it. When is it going to get done? How should it be done? And one thing to take into consideration is what I'll label as early stage moisture mitigation and leveling. And when does early stage? Early stage can be as early as 3 to 7 days after concrete slab installation, as opposed to months later prior to the floor covering being installed. And that's sort of different than when it's handled. But again, by early stage moisture mitigation and leveling, there's some savings of time and money. One, moisture testing. You're going in with the membrane. There's no need to test for moisture because, again, you're putting down 100% RH resistant coating down. So again, moisture testing, the cost and time for it is eliminated. Surface prep. We talked about curing compounds earlier, that if a spray applied curing compound is used, you're going to have to prep the floor, remove it mechanically. Well, by using the moisture mitigation membrane early and covering it or protecting with a leveling compound, you don't have that concern any longer. You may potentially use less self-leveling product. Once concrete is placed, it can be perfectly flat, if you will, within the first few days of installation, but weeks, months down the road, as that slab dries, it will curl, it will deform at joints and perimeters or edges. And that curling can create a gap of several inches, as we see in the slide here, underneath that straight edge. So by applying moisture mitigation early, holding moisture in that slab earlier, the amount of curl or deformation is greatly minimized, again, using less product for leveling down the road. Also a concern with moisture mitigation when it's done or planned for, let's say, soon before flooring installation, particularly if no one's thought about it, if it's not specified, there's no funding allocated for it, who's going to pay for it? So to avoid that argument, who's responsible for the payment, who's responsible for the installation, by early moisture mitigation during the slab installation, you save some of that debate. And in addition to flooring that has a certain flatness requirement, in the case of porcelain tile, you want a slab that has variation less than 1/8 inch in 10 feet. But there's a lot of trades and their products that are affected by floor flatness. So rather than, again, at the 11th hour of floor installation or other materials, you've got that corrected. So scheduling is not interrupted to make take remedial steps relative to moisture and curl of that concrete slab. So again, early stage moisture mitigation leveling can solve a lot of the problems with floor slab condition prior to flooring installation. This is not often done, and the benefit possibly you won't see until other trades are starting to work over that slab. Something to consider for specifications. All right, I'm done with my presentation. If there's any questions, I'll gladly answer them to the best of my ability. Jim,
nice job, Howard. Nice job.
Yes,
I appreciate it. At this time, we have one question. I think that goes to the detail you gave out. It was so well done. And this is a fairly simple question, and it's just asking, is alkaline deposit the same as efflorescence?
They're both salts that come to the surface. Alkaline deposits, and I've asked that in question, I think chemically, if you will, they're identical. It's where they appear and what they do. But if you're seeing your grout, for example, that has a whitish deposit on it, most people will respond to that. That is efflorescence. If you see on something underneath the flooring, that will be an alkaline deposit, where I think, not being a chemist, but for all practical purposes, efflorescence and alkalinity deposits are the same chemistry. I could be wrong there, but they're both a product of moisture being driven through a material that can supply alkaline salts. It can be concrete, it can be cementitious mortar, it can be cementitious grout. It could even be in the groundwater, if you will, high alkalinity. So,
Great.
is that a good answer? It's the
Yep,
best
we've
you're
got a
going to
couple
get out
more
of me
here.
at the moment.
Yeah, we've got a couple more questions that have come in, but before we do that, I want to make sure everyone that attended today, if they're looking to get a AIA accredited CEU for today's webinar, please look at the chat screen for Howard's email address to mail him your request to receive it. So I want to make sure everybody looks at that. And Howard, our next question just is, could you reiterate what MVER is?
Moisture vapor emission rate, and the unit of measurement is pounds of moisture per 1,000 square feet of floor in a 24-hour period. So when you do a MVER, moisture vapor emission rate, you're typically you're required to do 3 tests for the first 1,000 square feet of floor, and then 1 test for each additional 1,000 square feet of floor, plus some tests. I forget. I think within I'm going to say within 1, 2, 3 feet of a wall. But MVER is moisture vapor emission rate measured in pounds.
All right, we got a couple more questions here. So this is Sarah Kent. I just want to let you know that I'll send out an email to you. All of these, as we stated in the beginning, all of these webinars are on our NTCA YouTube page, and you can go there, and within 72 hours it will be up there, and you can watch it there in its entirety. All right, let's see what this one says. It says, someone here says, I believe most of this information is for new concrete. I will have a project with old concrete, some almost 100 years old, interior work. Do I ask the contractor about the same type of testing and information? Good question.
Well, yeah, you're right. You're probably right. I think looking back now, I'm talking about new concrete, but everything I said, again, the testing is applicable to old concrete or new, meaning months old versus years old. So again, the same type of testing, if it's several years old, you're doing MVER and or RH, depending on what the flooring manufacturer or floor covering manufacturer recommends or suggests. So everything is still applicable. I think that answers the question. Again, this is not just for new concrete. It could be for concrete that's many years old. And I think the illustration was that floor that was trenched and then had moisture mitigation problems. So new concrete, old concrete, all this applies.
So one of our attendees here wanted to make a comment that in regards to vapor barriers, ANSI requires one under the slab that extends up the sides. Is that your understanding, Howard?
Yeah, that's correct. Wrapping it up the side, because again, you've got, that would be recommended. Again, because the slab, you got a soil, you may have moisture wicking in from the side laterally. So moisture, the barrier running up the side is very important.
Oh, here's a good question, Howard. So do you recommend a flooring contractor conduct the MVER or the RH testing, or would it be best to hire a company that specializes in conducting these types of testing?
Well, I would say that they have experience and do the testing regularly, because in some instances, there may be some interpretation of what you're reading there, reading the floor, understanding why you might be getting high values and things of that sort. A flooring contractor, if he does this as part of his package of services, he's trained, he's done it, then I'd say you'd be okay. But understand too, the flooring contractor has a vested interest in having a dry floor. Whereas, and I'm not saying they'll be dishonest about what they measure, but I'm saying a flooring contractor, independent or a testing contractor, his results are not, he's a little bit not concerned, or he's not dependent upon whether or not his values are conducive to a flooring installation, meaning making the contractor happy. So I can't say, but I would go with an independent testing lab testing company as opposed to the flooring contractor, but not to say that a flooring contractor can't do it correctly.
All right. All right. Will moisture traveling through the subfloor from failed undergrade plumbing deteriorate the bond of cementitious thin mortars to the tile and or slab?
Yeah, moisture from a leak or plumbing from whatever the source can. Well, in the case of flooring, soft flooring, as I use the term, the adhesives may not be resistant to moisture. So if you've got moisture coming from the top, seeping through or wicking through or whatever through the joints of the flooring system, yeah, that can defeat the, create problems, many similar or exactly as we saw.
What about though with cementitious thin sets for a tile, whether it is porcelain or a red clay tile? Does it make a difference? Does the plumbing deteriorate? Does the water deteriorate those?
You're probably all right because, again, I made the point that we install tile in pools and water features and showers. So
Right.
it's fine there. So really the setting materials underneath the tile, once they're fully cured, correctly cured, they are moisture resistant. Where we may see problems is the formation of efflorescence that's driven up through the grout joint, or you may have alkaline deposits that if that's aggressive enough can cause disbonding of the mortar, for example. But generally, okay, again, we get how many square feet of tile in wet areas that performs correctly if the setting material is properly cured, properly applied.
Great. All right. We've got some people saying great seminar. Let's see. Here we go. One of our attendees has a school being built in a swamp area. The concrete has been poured and we will be installing quarry tile. Any special procedures used to ensure our tile installation process will be within standards? I'm assuming definitely the testing is important.
Well, the testing is important. Remember, there was a slide earlier where I showed water shooting up out of the floor like the Bellagio fountain in Vegas there.
The first one.
Yeah, that is hydrostatic pressure. I don't know the history of that slide, but I think where we had the floor was installed in a lower area or at the bottom of a slope or hill, and all that water coming down the hill is what created that fountain effect there. So I would think if you're installing a slab that you've got, again, exterior waterproofing on the foundation, as well as some sort of drainage system installed on the exterior, or sump system on the interior. Again, I don't do concrete installation. There may be better comments from a concrete contractor or an engineer.
Howard, let's go with this. So now, would this installer, would it be important for them to have an outside source come in to review this of some type before they get into this if they're not comfortable?
I would definitely do that. If you're telling me it's in the swamp, the concrete's been installed, yeah, I see a red flag waving right there that you've got great potential for problems. And
all right, Jeremy,
third-party verification probably would be a good idea.
I agree. Jeremy, if you look on the chat screen, you'll see Howard's email address. If you want to send him an email about that, maybe he can help you identify the right service to help you out in that situation. All right, the next one is taping a piece of poly down and checking for moisture an indicator?
Yes. Believe it or not, there is actually an ASTM standard for a qualitative measurement of moisture, where you take down a sheet of plastic 18 by 18 inches. I think leave it down for 16 hours. And if you see condensation underneath there, you probably have got problems or will have problems. It's a qualitative test measuring moisture at that moment in time. So with a sheet of plastic where that might be used, you're a contractor, you walk on a job and your leg starts twitching, you've got a gut feeling something's not right here. You want to you think there's some hot spots of moisture, for example, tape down some plastic and you get a a quick down and dirty result within a day. So again, if you see moisture underneath the plastic, more than likely you're going to see moisture underneath that flooring system at some point in time. But again, there is an ASTM standard for that. So people want to point finger at it and say, you're nuts, that's not very accurate. Well, there's an ASTM for it. How's that for an answer?
All right. So our next question, I think there's an easy answer to this, but our attendee is asking, we need to stand our ground with home builders regarding installation schedule during rainy seasons because of slabs and not being covered, or slabs not being covered.
I would say that that is correct. Was that the question? Yeah. Should we do that? Stand your ground? It's very much the case there. Because all these issues, many of these issues, if you're being proactive, might be disruptive to a budget, might be disruptive to a schedule, but installing a floor and then trying to address these problems after the fact is a real nightmare. So pick where you want to do a battle or spend time and money. After the damage occurs is not the best place to be spending time and money, unless that's your only option.
Well, Howard, you did a great job presenting this. You did a great job of answering these questions. We had over about 85 attendees here, and I want to thank them for their time. I want to thank you for your time, Howard, and I want you all to look forward to our next webinar, which will be March 2nd. Invites will go out, and here comes some more questions. Let's see what we got here. Who do we contact for a certificate? Ellen, if you look at your chat screen, please note the email address for Howard Jancy. It's howard.jancy@cbpmail.net. And you can just email him and he'll help you.
Yeah, if you have questions about the presentation content or a future installation, feel free to call me. Depending on what part of the country, I may forward you to my counterpart somewhere else. But yeah, feel free to chase me down and we'll get you taken care of as far as your questions on floor covering installation.
And for the AIA CEU, you could look at the screen here right now. Howard has his email address right on there. You can definitely send him and ask him for your certificate. So please look there, Ellen.
Jancy works or Howard .jancy@cbpmail.net. Either one work.
All right. Okay. Well, I want to thank everyone. I want to thank you, Howard. Great presentation. Everybody look forward to seeing you soon. And just remember, Coverings is coming up in about a month and a half. Hope to see you all in Orlando. It'd be great. So thanks, Howard. Take care, okay?
Thank you. Thank you, attendees. Have a great day.